Welcome to the channel. So today I'm going to be starting on a simple project that just about anyone could do. So I make a lot of small wood projects out of wood that I've cut here on my property. For example, I'm in the process of putting together a little wooden box for my daughter out of some lumber that I cut with a chainsaw mill and have air dried outdoors in a carport. Now, before assembling the box and bringing it inside, I need to reduce the moisture content of the wood a bit. Otherwise, the change in humidity levels will have a tendency to warp or twist the boards. Now, I have dried boards inside the house, and that does work, but it takes a really long time. I've also used the wood stove, but the intense heat has a tendency to crack or warp the boards fairly easily. So I have an idea in mind for a safe, simple, and fairly inexpensive mini wood kiln, but maybe a more generic term like a heat box would be more appropriate, because I have a lot of ideas for its use beyond just drying out wood. So I only run the wood stove out here in the shop if I'm going to be out here for a few hours, so it definitely gets cold and damp here in the winter time, and that can cause a lot of problems when things like wood glue stops flowing properly or can get stuck inside the canister. I've also had problems with spray paint adhering to metal pieces when it gets too cold and damp. And recently I put these gloves out here in the shop and came back the next day and they had grown some kind of a mold or mildew on them. So it'd be nice just to have a little heat box here in the shop that I can use to warm up materials or to dry out damp things like my gloves or even a dust mask. I'm trying to utilize materials which I already have on hand as much as possible, but I did purchase this Sterlite plastic storage container. It was just about the right size and it's already pre-made. It only costs $5.99. Now for the insulation, I have some of this reflective bubble insulation left over from a prior project. And I'm going to need a vent hole, so to cover the vent hole, I have this standard window screen, again, left over from a prior project. And I think the top on this Sterlite container, it's rather thin and it may not hold the heater very well. So I do have some 1/4-inch plywood that I can use to replace the top. And this is a Nesco food dehydrator. Now, until recently, I was using this inside the house to make raisins and dry out apple slices and things like that. But we got a new one for the house, so this one got downgraded for shop use. And there are cheaper models, but what I really like about this one is the integrated thermostat here, and also the thermal range is between 95 Fahrenheit and 160 Fahrenheit, which actually is a really good range for drying out most species of wood. And on the lower end of the range, 95 degrees, it's no hotter than a hot summer's day, so I'm not going to be concerned about melting glue bottles or exploding paint cans or things like that. And also the heater and fan are integrated into the top, which is easily removable, so it should be fairly easy to adapt this to a heat box. And finally, it has a thermal cutout fuse, so if the unit gets too hot, it'll just shut off the power. So the way this works, there are a couple of air vents on the top side, but the primary air intake is actually on the bottom. That's this hole here. So underneath this black circle is a fan, and underneath this one is a heating element. So the fan draws in air into this air intake, blows it across the heating element, and then hot air escapes out of these slots around the perimeter. And that creates sort of a circular airflow motion, which I think is going to work out great for the heat box. So all things considered, I think this is a superior solution for a heat box relative to, say, a space heater or a heat lamp or something like that. But it does have sort of a strange mounting solution, so I still need to figure that out. So the way the heater mounts to the trays, you'll see these little alignment pins, but essentially it's just sitting on these two outer ledges here. And there has to be a gap between these ledges to allow for airflow, and there has to be a hole in the center to allow for airflow as well. And so there has to be some structure between the hole and that inner ledge. And I was initially considering maybe routing out these gaps and making a hole and so on into the top of the box, but I was looking fairly time consuming, and I was concerned that it would be difficult to get everything lined up properly. But then I realized that, you know, these trays are already the perfect mounting solution for that heater. So all I really need to do is cut a single large hole into the top of my box and sacrifice one of these trays as sort of a mounting adapter to adapt the heater for use in my heat box. So this piece of wood here is going to get super dry, obviously, and so to help prevent the chances of it igniting if it happens to catch a spark or something like that, I'm going to go ahead and spray it with this high heat spray paint. Okay, so my heat box needs a vent hole, but I wasn't real sure what size of hole I need, so I thought I would look at the food dehydrator. You'll notice here I have a slot. There are actually 3 of these slots, and I measured them at 1/4 of an inch wide by 3 inches long. So I thought I would just calculate the area of these 3 holes and then drill a hole with the same area. So if you remember your high school math, the area of a circle is pi r squared, so that gives me a diameter of 1.7 inches. So if I drill a 1.7 inch hole, that should be the same area as 3 of these slots. So I don't have a 1.7 inch drill bit, but I do have a 1 3/4 inch hole saw, and that should be close enough, I believe. So this will be my vent screen, and I've never used this before, but I'm going to be trying out this Liquid Nails Flex 5X construction adhesive, so we'll see how it works out. Well, I will say this, that adhesive was very, very sticky and messy, but I think this is going to work just fine. There's the other side. So this box has a much larger volume than the dehydrator trays, so I went ahead and added insulation both to the top as well as the interior. Now I glued the insulation to the top because of gravity, but I didn't glue the insulation on the inside here. I just taped it in 4 places. That way I can just remove the tape, and this whole thing comes out as a unit in case I ever need to replace it or to clean it out. And I was in the process of taping all the seams, but I ran out of aluminum tape, so I'll have to get some more. But this is good enough to start some testing. So I'll be running the heater overnight at times, so I was curious to see just how much power it actually consumes, and it looks like it's just below 500 watts. Now I'm not going to want to run the heater overnight all the time, so I picked up this handy little timer from Amazon, and it allows you to select the amount of time you want the device to be turned on between 1 and 8 hours. And what I like about it is just a single button operation, so it's super simple. I won't need to try to find instructions or figure out how to program something. And it also gives you a on-off button, because otherwise the heater just comes on when you plug it in and goes off when you take the plug out. But now I actually have this little switch. Okay, so I want to see if my heat box is working, if it can get up to temperature and maintain temperature. That'll give me an idea if the insulation is sufficient. So I have a little thermometer here, which has a humidity reading as well. So it's 53 degrees Fahrenheit right now and about 79% humidity. And I'll put it inside here on this stack of blocks just to get it up off the floor and away from that vent, which may impact the temperature a little bit. and we'll see what happens. It should get up to somewhere around 100 degrees. I have it set just between the 95 and the 105 there. So we'll see what happens. The humidity level should drop as well. Okay, well, it's been about 10 minutes and I've peeked in here a few times, and every time I do, the temperature is really close to 100 degrees Fahrenheit. And as you can see, the maximum temperature is 101.6. So it's maintaining 100 degrees really well. And hopefully you can tell that the humidity has dropped off dramatically as well. It's now down to 25%. So yeah, I would say that this test was a success. Okay, so these are the wood pieces that I want to dry out a bit. I have them strapped up just to minimize any warpage while they're drying. So let me take a quick moisture content reading. We're about 13% there. Let's take one more. 14%. So I want to get these down to about 6 or 8%. And I have no idea how long it's going to take, but I'm going to go ahead and put these in the box, and I'll set the temperature to its lowest setting, and I'll just let it run overnight, and I'll come back and see what we have tomorrow. Okay, it's set to 95 degrees Fahrenheit. Okay, so it's the next day, and the boards were in the box for about 16 hours at 95 degrees Fahrenheit. So let's take another moisture content measurement. Okay, it's now reading 0%, so the moisture dropped quite a lot, and now it's too low for this detector to pick up anything, which is great. That means that my heat box is definitely working. This is a little lower than I expected, but now I know it doesn't take quite so long to dry out these 1/4 inch boards. And next time I'll just use my timer to reduce the drying cycle time. So since I started this project, I've come up with even more uses for a heat box, like shortening the dry times for adhesives and for wood oils and wood stains and things like that. Now, I've not seen anyone use a food dehydrator for this purpose exactly, but I'm really happy with the way it turned out. And, you know, I already had most of the materials on hand anyway, and in fact, the only thing that I purchased was the plastic box and the adhesive, so I'm only out about $10 out of pocket for this project. But if you were starting from scratch, you could definitely make a more efficient heat box by using some insulation boards, or maybe even an old camping cooler. So anyway, I hope this was useful or informative in some way, and we'll see you next time.